Hey, are you okay?
Who are you?
I'm part of your subconscious. I'm here to help you with your math.
My math.
Your math.
The test tomorrow?
The test tomorrow.
The one I'm woefully unprepared
The
for?
one that you are woefully unprepared for.
It's mostly because my teacher is nowhere near as handsome, funny, charming, and intelligent as Mr. Yang.
Let me show you the way! A vertical asymptote is an imaginary line on a graph that the graph will approach but never touch. As the graph approaches this line, it either goes to positive infinity or it goes to negative infinity. Here, as we get closer and closer to 2, the f of x becomes more and more negative, approaching negative infinity. Make sure you're testing from the correct side of the test number. If there's a negative sign next to the 2, you will approach the number from the lesser side. If there's a positive sign, then you approach from the greater side. Awesome, let's move on to the next topic for your test. Now let's do horizontal asymptotes.
Isn't that like a vertical asymptote, but parallel to the x-axis?
Yeah, but the method you use to find them is a little bit different. There are two main ways to do that. For the first method, you will compare the degrees of the numerator and the denominator. For the purpose of this example, let's say that f of x is equal to n of x over d of x. If the degree of n of x is greater than the degree of d of x, the horizontal asymptote will not exist because the graph will continue upwards or downwards instead of traveling towards a horizontal asymptote. For example, with 6x to the 6th minus 3x squared plus 2 over 9x to the 5th minus 3x plus 1, the degree is higher over lower, so the horizontal asymptote is positive, so there is no horizontal asymptote, therefore the limit is positive infinity. If the degree of n of x is equal to the degree of d of x, the horizontal asymptote is the leading coefficient of n of x over the leading coefficient of d of x, so a over b. For example, with 3x squared plus 2 over 2x squared plus 2x, the leading coefficients are 3 over 2, which is the horizontal asymptote. If the degree of n of x is less than the degree of d of x, then the horizontal asymptote is y equals 0. For example, with 1 over x, it's lower over higher, so the horizontal asymptote is y equals 0.
So is that the only way to do that? Because that seems like a lot of stuff to remember.
Yeah, there's another way, let me show you. So for this method, you divide every nomial in the fraction by the highest degree variable. So in the example 4x cubed minus 2x squared over 2x to the 4th, you would divide every nomial by x to the 4th, bringing you to 4 over x minus 2 over x squared all over 2. The 4 over x and the 2 over x squared go to 0 because if you put a digit over infinity, it approaches 0. Therefore, the entire fraction becomes 0 over 2, therefore 0.
Alright, I think that makes sense. So limits as they approach positive or negative infinity are horizontal asymptotes?
As long as they approach a y value, it will be a horizontal asymptote. There is one more way to make finding limits as x approaches positive infinity easier. If you know the behavior of different types of functions, you can find the limit as x approaches infinity without doing any math. As they approach positive infinity, logs will grow the slowest, radicals the second slowest, with polynomials growing faster than these two, and exponential functions growing the fastest. No matter what x value you plug in towards positive infinity, these functions will grow in this order of rates. Remember, a slower numerator and a faster denominator result in a horizontal asymptote of y equals 0. Here, now you try this one.
Well, because there's a radical on the top and a log on the bottom, and I know that radicals increase faster than a log does as it approaches positive infinity, that means that there's not going to be a horizontal asymptote, and it's just going to increase until it reaches positive infinity. So because the numerator increases faster than the denominator, it will approach either positive infinity or negative infinity based on the sign.
Yeah, that's right. Well, I think my work here is done.